Hello guys, in this video we are going to discuss the solution of the problem merge two BSTs. So let us look at the problem statement. The problem statement says given two BSTs, return element of merged BST in sorted form. So for instance, if these are the two BSTs which are given to us, the sorted form of merged BST will be given by 1, 2, 2, 3, 3, 4, 5, 6, 6 and 7, and that is what we are going to return. So that's about the problem statement, folks. Now let us discuss the solution of this problem. So essentially, in the question, two BSTs are given to us. And what we need to do is, we need to return the merged BST in sorted order. Now since it is a BST and we need to return in sorted order, what we are going to do is, we are going to perform in order traversal. So essentially, the core idea over here is, perform in order traversal of BST 1 and 2 and merge them. And folks, the reason why we are performing in order traversal is because the in order traversal of a BST will give us the elements in sorted order, which is what we want to obtain. So this is the core idea behind solving this problem, folks. Now in order to do this efficiently, what we are going to do is, we are going to perform in order traversal simultaneously. Now let us take an example to understand this. So let us say these are the two BSTs which are given to us. Now let us perform in order traversal of these two BST simultaneously. Now when we do it simultaneously, what will happen is, we will reach to this position, and within these two positions, since one is the smallest, what we are going to do is, we are going to print one first and then move on to the next element. Now as in order traversal, this pointer will move to this position. So now we are at a position where the elements are 2. So this is also 2 and this is also 2. So we will take 1, 2 at a time. So this 2 will come over here, and let us say we picked this 2. So in such case, the pointer as in order traversal will move to this position. At this position between 2 and 3, since 2 is smaller, so we are going to pick 2. And then this pointer will move to the next position, which will be this. And in this way, we will be able to perform the in order traversal, and we will be able to merge the elements of the BST. So let me complete this by merging the in order traversal of these two BSTs. So the merged element will look something like this. So folks, as you can see, the core idea behind solving this problem is in order traversal. And what we are going to do is, we are going to use the iterative version of the in order traversal. So the next thing which we are going to take up is, we are going to discuss the iterative version of in order traversal. So for that, let us take a tree. So let us say this is the tree which is given to us, and we want to do the in order traversal. So the way we perform in order traversal is, we are going to push the root onto a stack. So we are going to take a stack and we are going to push root onto the stack. So 2 will be pushed onto the stack, and then 1 will be pushed onto the stack. So let me write it down. Push root onto the stack, and then we update root by root equals to root of left. So in this way, if you see, we have pushed 2 and then 1, and after that the root becomes empty. Once the root becomes empty, what we are going to do is, we are going to pop an element from the stack. So let us say this is my stack S. So we are going to pop an element from the stack, and we are going to print this element. So cout root of data. And after printing the root, we update root by root equals to root dot right. So folks, what we are doing over here is, in a binary tree, and if we want to perform the in order traversal, we first have to operate on the left part of the tree. Since we are pushing all the roots onto the tree and we are moving to the left part of the tree, because of which the top of the stack will have the leftmost item onto it. So in a way, we have operated on leftmost part of the binary tree. Now it might be possible that this tree has right also. In such case, we have to operate on the right part of the tree, because of which we have updated root by root of right. So let us stick with this example and we'll illustrate this part as well. So for now, 1 we have printed. So let me write it down over here. 1 we have printed and 1 we have popped from the stack as well. And we have updated root to be right of 1, since right of 1 is null, because of which root is null. But since stack is not empty, there exists an element on into a stack, because of which we are going to operate on a stack. So again, we are going to pop an element from the stack. So 2 will be popped, and we are going to print 2. And then we are going to update root equals to root of right. So now root is equals to 3. So root is at this position. Again, we are going to push this 3 onto the stack and then update root equals to root of left. So essentially we are performing these two operations. Since there isn't exist left of 3, because of which root becomes null, so what we are going to do is we are going to pop an element from the root. So root becomes equals to 3, and this is what we are going to print over here. Then again we are going to update root equals to root of right. So this comes over here. So 7 will be pushed onto the stack, and since left of 7 exists, so we are going to push 6 onto the stack, and then we are going to pop an element from the stack. So 6 will come over here, and again we are going to pop an element from stack. So in this way, if you see, we have performed the in order traversal. So let me write down the pseudocode for this, and then we are going to discuss how we can perform in order traversal of two trees simultaneously, and how we are going to merge the in order traversal of two binary tree. So let us say root is given to us and we want to perform the in order traversal. So what we are going to do is we are going to take a stack and we are going to operate on tree while tree is not empty or stack is not empty. And the first thing which we are going to do is we are going to push all roots onto the stack. So while root, and let us push root onto the stack. So s dot append root, and let us update this root equals, and let us update this root by root equals to root of left. And in this way, if you see, we have pushed all the roots onto the stack. Now what we are going to do is we are going to pop an element from the stack and we are going to print that, and after printing it, all we have to do is we just have to set root equals to root of right. And folks, this is the iterative version of in order traversal. Now let us see how we will be able to use this in order to perform in order traversal of two trees simultaneously, and at the same time how we will be able to merge the elements in sorted order. So let us discuss the pseudocode for this problem. So let's say we want to merge two BSTs. So the first thing which we are going to do is we are going to take two stack S1 and S2 and an answer. Then we are going to iterate on root 1 or root 2. So while either of them is not empty, or len of S1 or len of S2. So folks, if you look closely, we are doing the same thing which we have discussed over here. While root and len of S, since we are doing it for two trees, because of which the other part also came into picture. Now after doing this, we have to push the root onto the stack. So for that, while root 1 s1 dot append root 1, and let's update root 1. So root 1 equals to root 1 dot left. So in this way, we have pushed root 1 onto the stack. The same thing has to be done for root 2 as well. So while root 2 s2 dot append root 2, and let us update root 2. So root 2 equals to root 2 left, and after appending this, we are at the leftmost position. So now let us choose one element of these two. So for that, let us first check if stack 2 is empty. If stack 2 is empty, then we have to operate on root 1, or stack 2 is not empty and stack 1 is also not empty. So folks, for stack 2 to be empty, len of stack 2 will be equals to 0. So that is why this not operation, or len of s1 exists and the top element of stack data is less than or equals to top element of stack 2 data. So essentially we are taking the top element of the both stack s1 and s2 and we are checking which one is lesser. If s1 is lesser, then we have to take s1 data. So for that, root 1 is equals to s1 dot pop. So the top element will come over here, and then let us push this onto our answer. So answer dot append root 1 data, and after operating on data, what we are going to do? Well, all we have to do is we have to set root1 equals to root1 dot right. And let us say if this condition is not satisfied, then we have to take elements from root2 or from S2 stack. So for that, root2 equals to S2 dot pop, and we will append our answer by root2, and let us update our root2 by root2 equals to root2 right. And towards the end, all we have to do is we just have to return our answer. So that's the pseudocode, folks. Now let us see how we have implemented this in Python and C++. So first let us look at the Python implementation. So for that, S1 and S2 and answer are there with us, and we are iterating on tree while root1 or root2 or len1 or len of S1 or len of S2, and then we are pushing all root of first binary tree on S1. Similarly, we are pushing all root of second binary search tree on S2, and then we are checking whether we have to take a node from S1 or S2, and that will be determined by this condition. If we have to take an element from S1, then we are taking an element from S1, we are putting that element on our answer, and we are updating our root1 equals to root1 of right. Otherwise, we have to take an element from S2, put that element on our answer, and then update root2 equals to root2 of right. And towards the end, we have to return answer. So that's the Python implementation, folks. Now let us submit our solution. So our Python solution got accepted. Now let us look at the C++ solution. So the C++ solution is also the same, folks. We have S1 and S2 stack and an answer. We are iterating on the tree while root1 and or root2 or S1 is not empty or S2 is not empty. Then we are pushing all root1 onto S1 stack and all root2 onto S2 stack. Then we are checking whether we have to pick an element from S1 stack or S2 stack. If we have to take an element from S1 stack, then we are picking one element on from the S1 stack. We are putting that element on our answer list and updating root1 equals to root1 of right. Otherwise, we have to take an element from S2 stack, push that element onto answer, and then update root2 equals to root2 of right. And towards the end, we just have to return answer. So that's the C++ implementation, folks. Now let us submit our solution. So our C++ solution also got accepted. That is all from this video, folks. In case if you have any question or comment regarding this video, please feel free to use the comment section and I'll try to address them. Thank you.